What I'm going to be doing is to present what the Institute is all about, as well as also the work that's actually been done. Okay, and there's two parts. Basically, firstly, the first part is looking at the context in which a lot of the work that we're actually doing in these very remote locations. So firstly, an introduction to the Institute. We are the Center of Excellence of Rural Informatics of Korea, which was upgraded to an institute about 3 years ago. And our main goal is to help rural communities in addressing their developmental needs. Okay? And how we are actually approaching this is we work with all the faculties in the university. We have members, research fellows from various faculties, and we try to ensure that whatever that is done is actually sustainable. So this one is James' going to be favorite place. Just to give some example, you don't have to work on that foot that 6 hours already, but this is just to show you how challenging it can get. We started with Barrio in 1999, and Lamai, Wayan, Larapan, Bacalalan, these four are from the TEX project, which was circa 2006 to 2008. So Lamai is the next award-winning project which I will actually showcase. So just to give you a bit idea about Barrio, because Barrio was the first one that started, so a lot of people know more about it. So to get there, you fly Twin Otter. So this is Long Lamai. In Sakutana community, there's about 400 to 400 people. They've been settled in that particular location for about 15 plus years already. And this is their community hall. A lot of the things have been discussed. And we do usually a community dialogue with them with the work that we're actually doing. So the faculty and engineering were involved in helping to build basically put up the solar panels, and the community were also involved in that using the satellite technologies. I think it's a very fast speed of 256K, making the first storm code. So we ensure that we give training to the people along Lamai, and they train we train the trainers, and the trainers will train the community. We also starting what we call an e-tabong, trying to get them to actually build a savings fund for improvements of the telecenter and other expenses. So that was more or less like the first half, so you get a taste of where we are actually working in. So now more towards the IT side of things. So one of the questions I always get asked is social informatics, what's it all about? I think the best way to think about it is most of us are working on IT. So we're looking at technology, looking at the algorithms, looking at the models and so on and so forth. So imagine that this is the ICT. The design of it, the use of it, its impact on community and so on and so forth is social informatics. So it actually covers in the sense in terms of the application and uses as well as the design of it. One of the problems in rural communities is, we are so used to Wi-Fi. The first thing you go to any hotel is, what's the Wi-Fi password? So in the rural areas, we also want them to give them that particular problem. They will ask, what's the Wi-Fi password? In places like Barrio, the community is not all in one location. Lamai it is, but in Barrio it's not. The 12 and 13 villages are far all over the place. So the challenge here for Dr. Tan and his telecommunications group was how to actually provide Wi-Fi, given the fact that those areas do not have electricity as well. So what was done was, through various experimentation and so on and so forth. So you have the telecenter with the VSAT connected to the internet. It's actually built to a relay station on top of a hill or mountain, and then it's actually what you call a long-range Wi-Fi. This is the MyClicks program, which the Chia was actually working on together with the colleagues from PAM. So the telecenter is here, the primary school is here. So the Japanese struck on the idea is, would it be possible to actually put in a fiber optic network in the rural community where there's no power? So this is the fiber optic network cable going through, and it is actually all powered via solar. The school there's actually Wi-Fi. So the key thing here is this fiber optic cable, which can go up to about 10 kilometers. You do not need electricity. It is also creating, this thing could also create other opportunities, because with the information that's actually collected, you can think about the GPS coordinates are collected. So say for example a plant called Tajam, which is this tree, is where they get the poison for the dart. Even though people think that it's a bit funny to go to do this. So I think that's it. Thank you.